Now, just by way of a quick review, atheists have argued that there's evidence there was worldwide fires, and the claim is then that the flood can't be worldwide because of the fires, and they have a problem with it over this. And I believe our study has shown that there could have been fires. I think there were after the flood. So we'll be looking at it some more, one more lesson, 2 lessons on this. Post-diluvian fires. Post is after diluvian is after the flood. We're going to look at evidence of an impact. I believe these fires were caused by 2 sources, perhaps 3, but I think 2 sources primarily. Volcanic activity, which was triggered by the flood changing the surface of the earth such that volcanoes began to occur. Don't believe the volcanoes occurred before the flood. No evidence of them. And my flood model would explain how they actually occurred, why they occurred. And of course, pieces or remnants of the rings of the planet and material that have been ejected from the planet, as I believe it was planet Mercury, whenever it was bombarded by part of its rings. And this right here, the material would come back in and be very hot when it comes to the atmosphere and create fires. The effects, what effects would a worldwide post-diluvian fires have there? There's evidence they were pretty much across the whole world, and that's very interesting. Iridium was evident in this burnt region, the part where we have the evidence of the fire. And there was iridium there and some other platinum group elements. And iridium is one of those. Iridium is found in cosmic material, that is, in material like in the rings of planets, and of course in meteorites. Meteorite, cosmic dust, and all have in them. But iridium is there. There's much more iridium in them than there is in the normal soil of the earth. So iridium is an element that's there. It's in the platinum group elements, a group of elements known as platinum group, right? Iridium. Evidence easily fits the hypothesis set forth in this class for a flood caused by planetary means that triggered the fountains of the deep to come up, that is, waters come out of the ocean due to tidal action. And of course, also the ice would have triggered the rainfall, taking water out of the canopy, and we would get rainfall. Remember, there was 40 days of rainfall, and there was 150 days breaking of the fountains of the deep, and 150 days of the windows of heaven. And so, just a moment. Yeah. And so, I'll turn it around the other way. Pull the air through like it was. The evidence fits the hypothesis that the organic materials were killed by the flood and left lying on the ground. By this, I mean a lot of trees and matter that could burn, debris, organic debris, and mostly plants. And of course, some animals, dead animals, would be there too. And the floodwaters receded from the earth and the organic matter then dried up. After the rain had stopped and the waters moved away, the organic matter dried up, and then it was able to burn at that point. I think the remnants of the rings of Mercury, I believe it was abundant that caused the flood, returned to the earth over 200 days after the flood began. Now remember, the 150 days breaking of the fountains of the deep. There's 3 passes for the earth, planet to go around the earth. It made 3 cycles around the earth before it was finally pulled away by the sun, probably aided by Venus. The Venus's gravity probably helped the sun pull it away, and it made a pass across Venus, near Venus, creating the retrograde action and rotation of Venus. About 200 days, 150 days, about 50 days for each rotation around the Earth. They give you 200 days. There'll be another 50 days back. The rings that were near the Earth were close enough to the Earth to not be pulled away toward the sun, but be pulled back to the Earth, and they'd come back about 50 days later and trigger this. That'd be enough time for the waters to have dried up enough for the fires to begin. These meteorites and or the eruptions of volcanoes probably caused the fires in the dried wood, and these fires spread as the floodwaters receded. As they receded, it's my contention that the Iridium anomalies, now anomalies is a fancy word for it, it doesn't follow the normal rules. There's more of it or less of it. In this case, there's more of it than there normally is in the soil. And this is in the region toward the top soil, the top layers of the crust of the Earth. The Iridium anomalies supply additional evidence that the flood was caused by a phenomenon that's been set forth in this class, because iridium is there in the cosmic dust and the meteorites. It's very common in them. The rings of the planet Mercury that probably caused the flood were no doubt made up of both ice, dust, and rocks. As we see the rings of the other planets, the Jovian planets like Jupiter and Saturn and Uranus and Neptune, the rings that they have. If these particles were attracted toward the Earth, they would rain down through the windows of the heavens on the Earth and impact the Earth. There would be an impact of these. They would come in at high speeds. They'd be molten rock, and if that hit some wood, it would start fires. And if pieces of it scattered it all over the Earth, it could trigger fires all over the Earth, which is exactly what we see. This dust and the small rocks would contain the same basic elements that are in meteorites that would account for the iridium anomalies. And there's some other platinum group elements that are there too. Here's a picture, and I'll give you the site where I found it. This is the sun. There's Mercury, and this is the dust cloud, the stream of it around their path. Venus here. Notice these rocks here that are there. Right here. I think these probably were part of the rings of Mercury as it circled back around and made 3 passes around and finally pulled away. It made a rotation path around Venus and slowed it down, made it go retrograde, and then it went into its orbit. And it left part of its rings, and that's what we see here, real fragments of those rings around here. There are also dust here around the Earth, and this is here. Here's a website that's the link that shows that. That's that website. You can look this up and find more information on this. And so that's there. Now, in Dobsley in Scotland, the iridium concentration line a range of 0.050 to 0.250 parts per 10 to the 9th power. That's a 1 with 9 zeros after it. That's a billion. And now the word billion in other countries of the world doesn't mean 1,000 million like it does in the United States. It's another number. So kind of keep that in mind. So I use parts per 10 to the 9th, or 1 part in 1,000 million. We'll call it 1,000 million for the sake of non-United States citizens who don't want to listen to this. Through a rock thickness, from the late or Deposition into the early Silurian. These are just some of the layers of rock that they've named through the 20 million years, and of course they've dated it by uniformitary geology. There's no iridium peak at the boundary, so there's not just a peak at the boundary. This occurs throughout its sample. The whole horizon has this in it. So what we see during the laying of this layer here and this concentration here, there was this extra iridium in it throughout that whole layer. right, in this boundary. This is your boundary region on the top layers. Dating of the rock at 20 million years is based on the uniform chain assumption. Now, this is the KT boundary, Cretaceous, the Tertiary boundary. It's labeled that by the uniform chain geology. If this rock was laid during the flood, it contained increased levels of iridium from either organic, volcanic, or meteorite sources, or a combination of these. Now, remember, we've already shown that there are organisms that will concentrate the iridium in just a few hours, or some organisms in 4, 5, 6 days. And these organisms could have collected the meteorite, the iridium and the meteorite dust coming in, and concentrated it in their plants. So that could actually have occurred during the flood. That would certainly fit the flood. That would be in accordance with the flood model. There's additional evidence that the flood was caused by a planetary body with rings, and it fits in with the model quite well. Understand that the fact that it correlates or fits the model doesn't mean it's correct, but it does conform with the model that I have. And all the evidence we have, if we keep seeing more and more of the evidence, conforms to the model. And so this gives evidence that my model is probably correct. I can't be dogmatic about it, and I'm certain it wouldn't make it a test of fellowship with anybody. This anomaly is easily explained by the rings of the planet, and I believe it was Mercury, being attracted to the Earth during the 3 or 4 passages of the Earth. I think there were 3.5 cycles around the Earth. It went around 3.5 times. The iridium in the Cretaceous Tertiary boundary, KT boundary, boundary was laid in the last stages of the flood, came from fragments of the rings which were separated from Mercury when Mercury went into orbit around the sun. And the trailing rings were pulled back to the Earth. They were close enough to the Earth to be pulled back. The distance of approximately 1 million miles from the Earth, the gravity of the sun and the gravity of the Earth are just about equal at that point. So any rings that were closer to the Earth than 1 million miles would be pulled back. Any rings that were further than roughly 1 million miles would be pulled toward the sun. And so the fragments of the rings would be pulled back, come back about 50 days later, approximately. Just about the right time for the wood to be dried out and have to start the fire. These fragments were closer to the Earth and were attracted back toward the Earth, as I just explained. They probably caused worldwide fires and the iridium anomaly at the KT boundary. That's my hypothesis, my claim, that it fits the model. Elliott et al. And others cited in the book linked the iridium anomaly to some kind of flooding event. Now keep that in mind, we'll get the side of them. The magnesium and iron peaks, Mg and Fe are magnesium and iron peaks, are interpreted to reflect mainly high glauconite concentrations in this interval. The lowest sample of high iron and magnesium is also the first sample with iridium concentrations above background. Now the background of something is what it has normally. And so, for instance, your body is radioactive, so is mine. And there's a background radiation. I'm looking at my desktop right now. It has radiation in it. The background radiation, a certain amount of radiation in that wood that's in my desk. That background radiation. Now, sometimes it can be put near a radioactive source that have more than the background. And so that's greater than the background. Background is what you normally see without the added iridium coming in, okay? Now let's go back and let's see what this is. This is 80 picograms per gram. Now, pico is a millionth of a million. PG is picograms of iridium per gram of iridium at 9.1 meters. It would appear that 9.1 meters is the depth within the sedimentary strata to which there was significant physical, including biodetermination. Now, biodetermination is biological organisms like animals that will bore into the bottom of a lake or the bottom of the ocean floor and burrow up into the ocean floor or the lake, bottom of a lake into the mud. or the sediment, and will eat things that have fallen to the bottom. That they'll eat plants and dead animals that have fallen, and they'll eat them. Biodetermination. And so what he's saying is there was significant evidence of significant physical biodetermination and or chemical communication between the sediments. So he's saying that the chemical, that is the iridium, organisms stirred it up and put it down in there. I don't think that's necessarily true. It wouldn't have to be true if this was all in the sediment as it was being laid during the flood. It wouldn't have to be biodetermination or chemical communication between the sediments and the surface environments in time the iridium deposition began, when the iridium began to fall. His view is that this happened over millions of years, and there was one event where the dust was coming in for a period of a few months. Well, my model will fit it coming in for a period of a few months, and this sediment being laid in a matter of a few days, maybe a few weeks, a month or two at the most. All right. So he's taken a long Earth, old Earth view, certainly, and he's forced to that view. This is his interpretation based upon that view. He continues on the interpretation of a 9.7 meter level as a flooding event is consistent with the increased glauconite content above 9 meters, which itself is consistent with open shelf conditions during a marine transgression. So again, he's making an assumption. Of course, the flood would explain every one of these problems or these scenarios. We should not, however, interpret what he says that there was a flood event. That we should not interpret this to mean that Eliot and those writing this article are claiming the biblical flood deposited the sediment. He just says it was a flood or some sort of flooding event. Right? Now, post-diluvian fires, what would they do? What's the result of them? Well, they would release a lot of heat from the fires burning. It would moderate the temperature of the earth. One of the things that has triggered some of the heat in the United States is the large forest fires. They put a lot of stuff into the atmosphere, which changed things. So these forest fires, post-diluvian fires would release heat. Remember, the ice that comes in was near absolute zero. It's probably 450 degrees below zero Fahrenheit, somewhere thereabouts. And so that ice being that cold, this would tend to warm up the atmosphere. Of course, this makes the atmosphere extremely cold, and only the organisms inside the Ark could survive this. But now the fires begin to burn, and they put warm air out into the atmosphere. Not only do they heat the atmosphere, they also would release large amounts of carbon dioxide, CO2, that would create a greenhouse effect to both the Earth to increase or raise the temperature, hold the heat in from the sun, came in from the sun. The greenhouse effect began to raise the Earth's temperature, and Wolbach says, lastly, the CO2, that's carbon dioxide, accompanying the soot. He's talking about this region, the KT boundary region, where there's soot, the evidence of fires, accompanying the soot, approximately 900 parts per million, would increase the greenhouse effect due to water vapor by approximately 8 degrees Celsius. Now, that's more than 8 degrees Fahrenheit, but we'll not go through that difference. By another approximately 9 degrees Celsius. So we have the effects of the soot, the burning, and also of the water vapor, both of them increasing the greenhouse effect and raising the temperature about 10 degrees Celsius. The bitter cold caused by the cosmic ice and ice has to be partially moderated by these fires. Be partially moderated. Keep that in mind. The smoke, large amounts of fires all over the whole Earth would block the sun's rays for a few months. But the darkness of the atmosphere would cause the atmosphere to warm up greatly, because the smoke and soot in the atmosphere would heat the atmosphere up, cause the atmosphere to warm up, because the black smoke, the dark smoke, would capture the heat and hold it in, so the air would get hotter or warmer in the upper atmosphere. That would be good and help to return the Earth back to a habitable place. The fires on the surface would more than offset the loss of heat from the sun. The smoke would block the sun's rays, would tend normally to, we just had smoke there and didn't have fires. That would make the temperature on the surface go down, but the fires would probably more than offset that and probably raise the temperature, and the smoke would then warm up the atmosphere. The fires probably occurred during the period of time after the floodwaters began to decrease, probably starting about 50 days after the waters of the fountain began to decrease, and before Noah left the ark. If you go back, he was in the ark a little over a year. In addition, the soot and charcoal would cover the ice and would greatly lower the albedo of the Earth. Now, the albedo is the ratio of reflection. An albedo of 0.5 means half of the sunlight is reflected back into space. An albedo of 0.9 means 90% of it's reflected back. If you have white snow, it will reflect back large amounts of the sunlight back into space, and it won't warm the ground up. So that snow tends to do that. I know across the Great Plains in North America, when we get snow in the northern Great Plains, it will tend to get colder because it's reflecting the sunlight back into space. However, if there's soot and charcoal that's covering the ice, that dark soot, dark charcoal, it would lower the albedo and make the black ice or the snow that's black, make it absorb heat rather than reflect it. Because a black object absorbs heat. That's one of the first things you learn in thermodynamics and physics, at least what we did. We learned that pretty quickly. Black object will absorb heat. It's possible this will explain the black ice of Job 6, 15 and 16, where the writer of Job wrote, "My brethren have dealt deceitfully as a brook," that's a stream, see, "as the channel of brooks that pass away, which are black by reason of the ice." So what is ice doing? Ice is not black normally, but they're black by reason of the ice. So there's a blackness to them with this ice. So the ice was black this time. That would fit this model, my flood model here, and wherein the snow hideth itself. The next verse talks about the drying up, warming up. So right here, it seems there was ice that was black in color, which would fit the model that we have here with the fires occurring. This would tend to increase the temperature of the Earth in the regions covered by soot and charcoal. The soot and charcoal would settle on the ice, and that would cause it to start melting. And it would capture the heat and would be reflecting heat from the sun. Black objects absorb large amounts of energy from sunlight. The albedo of snow, if it was covered with a lot of soot, would be almost zero. It would not reflect hardly any sunlight. Most of it would be absorbed, depending on how much soot or carbon there was on top. Carbon is black in nature. Okay? If fires of a worldwide nature occurred, there should be evidence in the sediments, which there is in the KT boundary and the KT region. Wallbach, Lewis, et al., and others found evidence at 3 different sites in Denmark, Spain, and New Zealand. Now that's on both sides of the Earth, of a worldwide carbon layer. All KT boundary samples gave about 1 to 2% of insoluble black carbonaceous matter. Now, what we mean by black carbonaceous matter, we mean stuff like you burn in the fireplace, that you get out of that, charcoal and things of that nature. It consisted of soot, charcoal, that's wood that wasn't completely burned, just partly burned, and kerosene. And all of these are produced by burning of wood. Another source, this goes on and says, under the scanning electron microscope, I I've never used an electron microscope. I've been in a site where they used them and watched them being used, but I was never in a position where I got to use one. I thought they were pretty cool. But under the scanning electron microscope, the carbon from all three KT sites, that's those three sites we just cited, and two of them in Europe and one in New Zealand, shows a bimodal size distribution. And that's bimodal, there's two modes. So submicrometer size particles, that's less than a micrometer in size, dominate by number and by mass. 82% in the Danish sample. Most show the characteristic morphology, that's the shape of carbon deposited from flames, such as soot or carbon black, irregular, fluffy, often chain-like clusters of spheroids. And we're going to have some pictures of some of these in just a moment. The impacts of the dust, meteorites, and meters, and meteorites, and other particles created objects called tectites. Now, we find tectites throughout the Earth, particularly in the upper layers. We find in other layers too, but we would expect it in other layers because we have these particles all during the flood occurring. We don't have the charcoal or the soot of the burning, and the reason we don't have that is because the water kept it from burning. But we do have the tectites, so they're found there. That fits my model still. These tectites, in some places, fits it. Tectites are found in the ocean cores, and here's a map of the tectites where they're found. In this would be North America here, Central America, South America. Here's Africa, Europe, Asia, Australia, and down in this region, Australia, and Asia down in here. Now we'll look at some more of this. Here's distribution of non-meteorite impacts. Look at the amount in the United States. Large numbers of. Now, the thing is, we may show more here because we've done more exploration and sampling and searching for them than some other places in the world. Some other places may not look for them, but they may be there. The fact that we haven't found them doesn't mean they're not there. If we weren't looking for them, we wouldn't have found them. There wasn't anybody out looking for them. There's more people in the United States and Europe looking for them, perhaps in India as well as perhaps in Australia. This is the developed part of Africa, South Africa region. And then we have over here in Chile, and this will be Argentina, in that region, Argentina, Paraguay, Uruguay, and perhaps. Now then, here's Australia and Asia, Asian Stringfield. These are where these are found. And again, this is where they've been found. They could be more in other places. They just haven't looked everywhere. Here's the distribution of tectites, Georgia tectites, and some tectites, large amounts of them here. Notice a lot of them over here that have been found. So these fit the layers that we see here coming back. And remember, the planet would have gone around in a path like this and would circle the Earth. Because the Earth is spinning and we would get that movement as it went across like that. Here's what some of these tectites look like that they just put on there. They're not real big now. They're not terribly large. But they have these irregular shapes, but of something that got molten and went through the air and moved, or maybe went through water and moved and cooled off. So there's what some of them look like. Now, they resemble charcoal from forest fires or marine sediments. Now, if you've ever taken some charcoal and put it under a microscope, you'll see some of these things here, which is also derived from wildfires. Some marine sediments have been fires, and fires can occur when the tide goes out, and could happen. The spheroid clusters, and these clusters are spheroids. These are called spheroids. They look kind of a little bit like a sphere, and they're spheroid clusters. They're presumably formed in hot gas or flame, and there's no other processes known to produce morphology. We don't know of anything else to produce it. Now again, I would point out the fact that we don't know of any other process doesn't mean there's not one. But it just means we don't know of another one. As far as we know, there's no other process that will produce it. So this fits what we see here. It fits the flood model, certainly. Since 1985, when they conducted their research, other sites have yielded the same evidence. So this has been expanded. I wrote from 1985 information. Large amounts of carbon dioxide, CO2, would have been required to stimulate the growth of plants. Now, carbon dioxide stimulates the growth of plants. It doesn't hinder it. In fact, the carbon dioxide presently being released by the burning of oil, coal, and gasoline, hydrocarbons, is causing the forest to grow in the northern hemisphere, according to CIS and others. I had other information that corn and wheat have also grown faster, and there's evidence that they've grown faster. Some of your food crops have actually grown more rapidly and produced more food due to the burning of hydrocarbons, coal and oil and gasoline. And so it's not all negative. Some of the worries about greenhouse warming from the CO2 emissions might be unfounded because the carbon dioxide, CO2, might stimulate the growth of plants that actually benefit mankind. And this is probably one of God's ways of rejuvenating the earth after the Great Flood. And He provided the carbon dioxide that would give the plants opportunity to grow rapidly. All the plants which grew during this period of time absorb large amounts of carbon dioxide. And see, there's C is the carbon, O2 is the oxygen. And what they do is they take carbon dioxide in, they give off O2, which we breathe, and they put the carbon in their stems and their leaves, and other things as well as they pull up from the soil, which are composed mostly of either carbon-12, and carbon has 6 protons, and this has 12 particles in the nucleus. That means 6 protons, 6 neutrons. Most carbon is carbon-12. There's a carbon-13. Both carbon-12 and carbon-13 are stable. Carbon-13 is still carbon because it has 6 protons, but it has 13 particles in the nucleus. It has 7 neutrons instead of 6, like carbon-12 has. But they're both stable. They don't break down and have radioactive decay. Most stable isotopes of carbon. To make them appear to be quite old, dated from radiocarbon dating tables. Remember how the radiocarbon works? It would take the carbon-12 and carbon-13, if they don't break down, carbon-14 would disintegrate and cease to exist and change back into nitrogen. So it wouldn't be there. So they would measure the amount of carbon-14 and project backwards and see how old it was. Well, the plants that grew at this time would not have any carbon-14 in them to speak of, so they would look very old by carbon-14 dating. So the carbon-14 dating, according to my model, would be way off on these plants. It appeared to be quite old, much, much older than that. In addition, the carbon dioxide from volcanoes, we've already seen that in a prior lesson. Volcanoes give off carbon that has carbon-12 and carbon-13, but almost no carbon-14, no radioactive carbon, no radiocarbon. And so we saw that plants growing near volcanic vents appear to be very old when the radiocarbon date them. And they would look older than their true age. Again, that would make a lot of things dated by radiocarbon be way out of kilter. The impact of the meteorites and the ice particles would produce carbon-14. There would be carbon-14 produced during this time. And we see this great increase in the radiocarbon in a short period of time. So that could happen too at this time. This is what Brown and Hughes claim happened at the Tunguska impact in Tunguska. And this occurred, we'll get more information about this in a moment, but account for whatever carbon-14 was in these specimens. So again, we would have an increase in it, a short increase for a short period of time. Here's the Arctic Ocean, the North Pole, and here's Murmansk, which is Russian for the end of the world. That's a Russian word for the end of the world. There's St. Petersburg on the house. There's Moscow. And I was lectured up here about on the Volga River, right up here about 250 miles north of Moscow, right up in here on Yaroslav. That's where I lectured in 93, 94. I was there. And that's not far from the Arctic Circle. But over here is the Tunguska event. There's something hit Tunguska and created a crater of some sort. They don't know what it was. There's several theories about it. And of course, Soviet Union wouldn't let anybody else in there to evaluate it. And probably can't get in now. This is, of course, probably not all the better people here. This, of course, is in Asia. That over here is China, Kazakhstan, and there's Japan. And over here is the state of Alaska up here. Yeah. So and this produced a bunch of radiocarbon. And we can't quantify the amount of carbon-12 and carbon-13 that entered the atmosphere through the fires and volcanoes, nor the amount of carbon-14 that entered through the impact of the meteorites. And ice particles during this period of time, there's no way to quantify it. So again, the whole system would be completely unable to get any accurate measurement of carbon. A number of plants require fires for their seeds to germinate. I think the redwood, the California redwood sequoia, I think it requires fire to help its plant seed to germinate as well. These fires provide the necessary conditions for these seeds to sprout, so they begin to sprout at that time. Probably the redwoods occurred at that time and sprouted up and began to grow about that time. There are three theories, and was our concluding remarks now. There are three theories about how the iridium got there, and these are the impact theory, volcanoes, and organic theory, that is, plants concentrate this. But the iridium had to be there for the plants to concentrate it. And the only way that we can really get it there is either through a volcano or through particles coming in from space, extraterrestrial particles. Now, the problem with volcanoes is the volcanoes that would spread it to large regions would be explosive volcanoes, and those kind, we can't find any that have large amounts of iridium in them. The ones like Kilauea that don't explode have more iridium in them, but not the ones that explode. You got two, basaltic and celtic lava. So there are two different kinds. One plugs the vent up, explodes, one free flows, like Kilauea. The events that brought about the flood also brought about volcanism, meteorite showers, and the demise of a number of organisms in short periods of time. So these plants then concentrated in that water. Volcanism, meteorite impacts were simultaneous, or virtually simultaneous. That's my model. Fires would have been started by either volcanism, meteorites, lightning, perhaps or by a combination of these. In these fires, which we find the evidence of them all over the world in the KT boundary, that's the upper crust of the earth, and this will fit my model. It's possible some organisms concentrated the iridium, or they deposited the sedimentary rock as well, but the iridium had to be there for them to concentrate it. The only two ways it could have gotten there would be by volcanic action, since it's widespread, or by coming in from extraterrestrial sources, meteorites, cosmic dust, or whatever. And remember the volcanoes, the explosive volcanoes don't have iridium in them, none of them that they know of do. So it won't fit. The volcanic theory won't fit. Volcanoes continue to erupt, but at a decreasing level in modern times. The atheist wrongly contends that the KT boundary claims were deposited over a period of several 100,000 years. That's what they contend. But the time interval represents about 250 centimeters. Now, 2.54 centimeters is an inch. So 250 centimeters would be, if you divide that by 250 by 2.54, it'd be about 100 inches, approximately 100 inches. As of an order of 10 to the 5th years. 10 to the 5th is 1 with 5 zeros after it. That would be 10,000 years. From an assumed sedimentation rate of 10 to the 2nd, that'd be 100 centimeters per 1,000 K is that kilo per year, per 1,000 years. What that, how that reads. And that's an assumed sedimentary rate. So we get 10 to the 2nd centimeters for every 1,000 years. No doubt they're posited under this much shorter time period, a few weeks or even a few days during the flood. All right. Now, do you have any questions?